Okay, shall we start? It's 2:05. 어디를 보고 해야 되는 거야? 여기를 보고. Okay. Hi everyone. Welcome back to the AAVS Seoul lecture series. Today we are gonna have a social series lecture. So the first speaker is Anna and Mathilde, who is joining us from UK. So it's very early morning. I don't know what time it is now. It's probably like 3 o'clock in the morning or something, isn't it? 6 a.m. Yeah. Thank you for taking your effort to get up so early. Here we are in Seoul. In this room, we have some tutors and students, and some other students are joining us from the studio. So let's welcome Anna and Mathilde. Maybe you can introduce yourself before you start your lecture. Thank you.
Thank you, guys. Thank you so much for the invitation. And yeah, I mean, fortunately, I'm in Barcelona and Mathilde is in Paris, so it's 7, so one more hour sleep that we had there. We're very excited to join you today, and we organized this. We're gonna speak for like 15 to 20 minutes each, and then we'll have another 15 to 20 minutes for questions. So we're gonna do that, right, Mathilde?
Yeah, I'm following you. So yeah, I'm very happy to, and lucky to be in Paris also. The sun is slowly rising. So for us, it's like breakfast with you, and we are very happy to be here and present.
Great. Well, I'll start then, and then Mathilde will continue after me. I'll start sharing screen then. I believe you can see my screen now, right? Yeah. Thank you. Okay, well, my name is Anna Font. I'm an architect. I studied architecture in Barcelona, actually, and then my master's at Harvard University. And I'm currently entering my last year of the PhD at the AA. That's where I met Mathilde these last couple of years. I do not say this without certain anxiety. That's my last year of PhD. I still don't know how I'm going to wrap up the thesis. But for me, doing the PhD was also key to reflect on what I do and to reinscribe all that into architecture as culture. That is a culture that I find is constantly evolving and complexifying. And it's in this context that today I'm going to show you 4 projects, 2 of them very briefly, 2 of them a little bit more extensively, because I find that in this kind of material, I start developing some ideas and principles that are constant throughout my work and throughout the way I research and I kind of approach any problem. I've called it material modalities because in a way they are all modalities of working materially at different scales. The first project I'm gonna show you is called Cumulus. Cumulus is a cashmere crochet membrane. It is conceived as a multiplicity of catenary surfaces that hang from one another in a sort of cascade of geometric iterations that escalate the deformation and subdivision of a single continuous flat sheet into a multiplicity of integrated catenary patches. This goes according to a progression that is iteratively double, like 1, 2, 4, 8, 16, 64, and 1024. As you can see in this image, this is kind of the process of iterative hanging of catenaries, a similar kind of procedure that arrives to this kind of final kind of net condition of the surface. This here I include because it's a variation of the field. Of course, this is scripted, and we were kind of working within the possibility of being it wider, being it narrower, exaggerating more this kind of turbulence that you're starting to see, and I'm going to elaborate more on that, especially in these ones, like how the vectors push against gravity, and this is something that is not achieved by the geometry, it's going to be achieved by the material. Because when we choose this degree, and this is the longitudinal, like here you have the longitudinal arches and here the transversal arches, and the project attempts to preserve and exaggerate this asymmetry nurturing a nonlinear behavior that controls the curvature of the surface through the increase of points in a crochet kind of technique. As you saw in the first images, this is made of crochet. So the increment of points works like against the gravity of the curvature of the catenary, and pretends to, by excess, intensify the pattern and then generate this asymmetry, this turbulence that diagonally organizes the surface. These are the catalog of the different arches. As you see, it sags more in the middle, so it increases, it's heavier in the middle, and that is where it contains more material. And this is made of self-similar parts, coming back to one of the first images I was showing you. So the piece can be understood as 1, but then it can be understood as 16, that then is progressively subdivided inside. This is not only a way to understand it, it's also going into how we are going to build it. We're going to build it by means of these 10 by 10 centimeter units that then are going to be, again, assembled. And here, the moment of choosing exactly the kind of wool that we're going to use becomes crucial, because of course we can say, okay, wool basically it's all the same, but it actually behaves pretty differently. So we start testing this patch, the minimum patch, in the different materials with the same measures and proportions to see how it behaves. So in a way, something that to me is interesting in this project is that we never produce a model that is the representation of what is going to happen. The model is a model of control, and what is going to happen is going to have a form that we never drew. We never really kind of produce. So from this let's say array, we are going to end up choosing the first one, as we found like the way the resolution of the folds, the softness of it, the way it filters light, it is getting where we want to get. It is not as much about knots like in this one, which is more, let's say, structured. I think there is something about being able to differentiate the knot or not, whether the swing between the units was visible or less visible, and we are choosing like this guy who is more homogeneous in that way. And this is how, I mean, this is the project in a way. Like each one of these patches has this pattern, because what we do is extrapolate, like the script, what it does is like translate the form into a crochet pattern. And this is the crochet pattern that defines, the technique consists of a series of local proliferation of points, as you can see here, like from stable points, it starts to kind of bifurcate and integrate more and more points. And the fact that this intensifies, it means that the textile is going to stretch, and this excess will be the differential curvature with this kind of precision. The increment in the number of points of each crochet line generates an elongation of the line, which in turn curves along its trajectory within the surface, and it differentiates itself from its adjacent lines. So each one of these patches that are here in piles has one of these crochet drawings. And this is being sewn by this bunch of women in Buenos Aires that actually have no idea of architecture. So basically they dedicate themselves to sewing, and they found that they were sewing and sewing. They didn't even know what it was. So it was very nice in the process, because they would start, and by the end of the day they would have like this kind of very long dresses in front of them, having no idea of what would come up, right? So that kind of extreme like differentiation between the control system and the effect was very interesting to, like, let's say, to discover in that process. This is when we go to the museum. This is in the Museum of Contemporary Art in Denver. And we hung the first kind of transversal unit, and we were preparing these nets that were holding each one, and they would potentially, and you'll see in a moment, join them, let's say, laterally one to the other. This is the process of hanging, and this is the final, let's say, piece already there in the atrium. I think, well, Cumulus, in a way, for us, unfolds a wide, let's say, spectrum of divergent and sometimes contradicting sensorial reminiscences, like it can generate a sense of oppression, weight, burden, but at the same time it's light and it's joyful. And it has, of course, a number of figural resemblances to complex natural formations, like, of course, broccolis, cauliflowers, brains, storms, I don't know, wombs, intestines, or turbulences. And all these things we were interested in. It also brings about an irreducible, let's say, presence of simplicity, a certain archaic exuberance, which works as an abstract means of enigmatic, for us, like manifold meaning. This is designed, as I was saying, to occupy the central atrium of the Museum of Contemporary Art, and it concentrates there this sense of figures and meanings in a single kind of slippery figure. And the color that you see is the light, the incidence of natural light, because this atrium has this skylight that comes down from the ceiling and somehow overwhelms the space with this intangible and very warm and dense atmosphere. And of course, like this is the dichotomy, right? Like this is how the model comes up to be, and this is how the model is drawn and controlled. This is the accumulation of crochet patterns. And I was interested here in showing this, let's say, this dichotomy, because in a way, and this next project is short, this is student work in one of the studios that we were teaching, which operates with exploration of material systems and different methods of fabrication without, let's say, fabrication tools, mostly what we had, because this is again in Buenos Aires and we had no other resources than just being in studio. And the relationship with the previous project is like, how do you define, in this case, the unit of lamination as part of the project? And not so much going only from the study of wood, but also of what you are producing. In this case, we proposed the students to design a chair, and they started investigating what it means to sit and what it would mean to generate this kind of horizontal surface. As you can see here, this is the same model with a degree of kind of laying down. Like this is the most horizontal kind of chair. This is kind of a semi kind of place to sit that is slightly bended, and this one is more straight. And of course, again, like the basic unit is it's the intelligence. I think it's the seat of the intelligence of the project, as before. So in this case, it's this kind of infinite form, this 8 form, that only by the variation of the point where this slides closer to the edges or to the center, it has a different rigidity, and also it has a different capacity to bend backwards and forwards to produce this kind of relationship with the ground, and also relationship with your back and where you sit. And then the idea of laminating, not only the idea of lamination as in, okay, lamination is a construction technique that we do to put, achieve rigidity, but also the lamination of the primitive unit, like the multiplicity of the unit as being what it becomes stiff, like opening up the lamination throughout the scales of the project, in this case of the chair, which is this kind of multi-lamination of laminations, let's say, no? And this is what opens up, again, this degree of variation. This degree of variation, in this case, it's not a selection of one of the states of it, but more like the assembly of the different degrees to produce like these different conditions of stiffness, and also of how you sit and how you behave in this kind of surface. This is the final. Well, the students produced an exhibition in the school. These are the sections of for example, of the 2 extreme degrees of this chair, and this is how dense it was becoming. They were doing everything by means of clamps and by hand, and this is what was happening. So again, like a problem of scale, a problem of not thinking that lamination is a problem of a construction problem, but more like an idea that goes throughout the different organizations of the project. And here I jump to something that to me it's the same. I mean, it's the same kind of project. It's just that we are looking at one particular organization, which is, of course, you know this is San Carlo le Quattro Fontane, and we were interested here in the internal surface of the project. literally just the internal surface as a surface that is made of different let's say conditions that we divided it, and I'm gonna follow through. But this is again student work in the same kind of seminar as before, but now thinking that it doesn't really matter with what you work. In this case, we work with these references, but it's not a nostalgic or mystical way to look at architecture, but quite the opposite. It's kind of to open it up again. In this case, we redescribed how to produce the contour of the project, which is interesting because in this project, the external surface of the facade folds in. I think this is probably the most interesting operation that Borromini does in this project, is the fact that the surface is continuous from exterior to interior. So we said this is the most important and interesting thing of this project, and this is how we would build it. Of course, with a lot of, I mean, you've seen this building 1,000 times, you've heard of it 1,000 times, but when you start drawing it, we actually found a guy that did a PhD on the plan problem, and we finally somehow understood how to build it up. So I think we were teaching a material seminar, but we were also saying, like, here the material is the organization of this form, and we extrapolated in this model of contours that would be the basis with which we would elaborate the final continuous surface. So this is a continuous surface. This was the first part of the course, where we kind of learned and taught how to actually say what is interesting of this is to understand it as a continuous surface, interior exterior, and how do you build that surface. So this is the model that we produce for that. And then the next challenge is to redefine this. We gave them brick. We gave them not brick as a material again, not like this is wood, this is brick, but more like the bonds that brick already has, which is a very deep feel of how we work with brick. Like here, I'm going to show you just 2 catalogs of the options of the different bondings. So we gave this to the students, and we said, now you have to transition through bondings to generate the conditions that are relative to the surface changing. So if the surface in the model is kind of producing this sort of more continuous curvature, more smooth curvature, then the brick would kind of rotate at a certain velocity, and then when certain protuberances happen, then this would increase. So basically what we're seeing here are, like, let's say, the samples with which the students know how to produce certain traits, certain conditions on the surface that are determined by how the brick, for example, opens in 2 sides because this is double-sided, or it accumulates, but it always stands, it always kind of produces this robustness, and also defines the surface in a very kind of small scale, as small as you want to go. This is the integrated project. Like, the students were working in different systems. For example, one group was working with the lintel, one group was working with the cupola, the cornice, then the pillars, the facade, and then we integrated all the projects in one again. Well, here you can see a little bit like all the units of bricks that are happening there. And this is the different layers. Like, if you contour again that model that I just showed with the bricks in the different lengths of bricks, these are the plans. So from the let's say floor that is more dense because it's full of bricks, to the very last moment where there are like 4 bricks holding up the final piece. This is the progression. This is the selection. There are more rows, right? I'm just selecting some of them here, and for the pattern you can see how it transitions to moments with the different kind of lateral areas, or where the cupola separates from the facade because the facade is only linked in certain parts, and these are the different lanes of bricks. This is how it looks from the inside at certain points. As you can see, while the orange emerged in the process of construction, we were adding certain bricks while we were building it up. This was very, very bottom up. We were building it with this drawing. Like, every one of these rectangles is an A3. We would print this and lay it out, and then here in every one of these plans there is the brick and the brick that is below that layer, and we would build it accumulatively, which is quite a challenge. It was this is some of the process of construction from above, and how it became too close, and then the video stops because the cupola starts growing. This is a moment before we raised the cornice to here, and before the cupola was built. Like with these guys, we could do until here, and then the following year we did the cupola and the lintel. And this is how it became. Now I'm getting closer to the last project. Like this is where we were doing this work, and this is a studio, and we call it in Spanish borrominillo. It's like a pocket borromini kind of condition. It became like an icon inside of the school, like something to revolve around in this space, and it is organized in the axis of the school. This is the building I'm going to show you now. Actually, I'm going to speak more about this building because the other project is also in the same position but in the floor above it. So this is Borrominillo, and this is the architecture studio, and this photo you were seeing, it's like taken from here with the Borrominillo in the back. And so it's, I mean, of course I'm showing this as the process, like the material process, and I'm speaking about the brick and how we describe the surface and what are the conditions that we kind of look for in order to generate this kind of novelty and investigation. But it's also a sort of cultural act that happened as a way to work together in this object. And Aula Magna, which is like a lecture hall, is a small lecture hall, is also located in this building. This building is here. This is the riverside of the city. As you can see here, it's more like a lucrative kind of area. This is the public university, UBA, it's called, maybe you've heard. This is River Plate Stadium, and this is the university here, which is this cloister. This is the building, and this is the axis I was mentioning. So that animal that I was showing, it's here inside this building, in this building, right? So I wanted to show you like this front, and then I'm going to show you the other view, the opposite view, because here, as you can see, the city is like there behind. So the skyline of the city is laying there. There is all this still space of green area before it becomes dense. And then from the other side, the river is kind of in the horizon. And I was showing you something that is here, and now I'm going to show you the room that is just here below. And the axiality, it is important for us because of how it integrates the projects in the overall construction of what is considered a campus that is growing. This is the plan of the hall. In this case, what we consider this a building within a building. In a way, I mean, it's a small building. It's like 12 by 12, but it's like a building within a building, and that's why this symmetrical line kind of holds it together. It is a space that it is organized, let's say, as a loop of circulations, with these entrances that are closer to the elevators, and these entrances that are linked to the office kind of circulation. It is a space that is thought as very like Miasian in a way. It's symmetric, it's open, but it's contained. It's diffuse, but it's very strict, and it spans within the limits. It has no columns or no supports inside. But also, we were looking for this kind of voluptuosity of expression that is proper of Michelangelo's Lawrenceana library, and I'm gonna show you why we think of that. Like, these are our two kind of references that are somehow like very extreme among themselves, but we're interested in this kind of multiplicity of frontality. I mean, it has a lot of frontality because it's a lecture hall, but at the same time it has a lot of parallelism. It has concentricity, but it also has a certain diagonality. I'm going to show you more this in the pictures, but in here in the plans, what is interesting for me here is that this is the plan of the floor, and this is the plan of the ceiling. This is one of the symmetries. It's not only symmetrical in terms of the plan having this side and this side, but also it's horizontal, like vertically symmetrically. And it is this very modulated structure. These are constantly 120 modules that then remodulate themselves, but as you can see here already, the modules are not constant. Like you can see these lines that go like diagonally modulating the different rows in different rates, making people be in 4s, in 3s, in 2s, in 1s, in different steps. And the same happens with the roof, or the ceiling, sorry. This ceiling integrates a number of technical systems, actually a pretty high number of technical systems, and the constellations that this generates and how they go together in the different panels was also a kind of miniature kind of work to produce. These are the sections. Here you can see like longitudinally how this is a concave kind of condition. Also in the roof is convex, and it opens up in this kind of belly, and these are the transversal sections. During the construction, again, it's very like petric. I don't know if in English that's the right word. Like it's very stony in the floor, and it's very metallic in the ceiling. But we wanted to embed everything into this kind of thickness. So this thickness became a sort of very detailed way to build the edges, to actually incorporate these installations. Again, multiple installations in the floor, multiple installations in the ceiling, but then with this finish of polished stone, and the whole process, both bottom and top. These were different people, like the people that were working into the polishedness of the bottom, and the people that were integrating all the installations in the top, that became progressively more and more invisible and embedded. The moment of sanding of this floor was generated a crazy atmosphere of dust, and here you can start seeing what I was telling you about the skyline at the back. Like the room frames this skyline back, and it also opens the plan. Like the plan was very deep, and let's say the hall, it produces a sort of window up on the hall and a window up on the city. And this is why I was saying it is a building within a building, because it is contained, it has an organization of its own, but then also it's opening the plan in such a way that you can see through it. And that was the ambition. The ambition was to produce this kind of Miesian box with this kind of voluptuous organization. Here, these are the final touches, but you can see how the tables are laid up, and how this diagonalization of the curvature is becoming apparent, and it's starting to kick in. This is some of the last images of how this looks like. This is from the lateral, as I was telling you. Like, it is interesting also in the first plan, you could see that there are two patios on the sides, so there is a lot of light coming in from the sides, and the blinds, we introduced double blinds to make this more or less, let's say, transparent and diffuse along the way. Again, this kind of constellation of conditions on the ceiling, which became, I think, integrated in kind of interesting ways. This is looking from one patio to the other patio. This is, let's say, another of the kind of symmetries, like the symmetry between front and back, and the different areas. We were very interested in thinking that this is pretty small in a way, but to generate different scales, as I was mentioning before, of aggregation, right? Like from this guy that's slightly higher here to becoming 2 and becoming 1 again, or this guy here, which is in the same row, but it has a very different way to relate to the front from the guy that is kind of just next to it. These are the different neighbor conditions, and it generates different ways of intimacy, and it has proved like this now that it's been working for a couple of years, that it does produce this way of sitting with your group in a certain area and being like in your own kind of space there. And yeah, well, this is one of the when the sun goes down and this kind of constellation of lights kicks in, and the outside also. So these are the two facades that I was mentioning before. This is the internal facade with the loop circulation that you can see here, the patios, and the really back facade inside of the object. And I wanted to finish with this project because this project had two outcomes that for me kind of link back to my own interest to always try to position and to kind of rethink where this sits in terms of what you are doing within the discipline, right? Not just like a punctual project that you kind of have the chance to develop, but what does it mean for what you are thinking? This is exhibition, these are the panels. I'm going to show you now the two panels. This is exhibition that Farshid Musawi curated in the Royal Academy of Arts that was about organizations, in like drawings of organizations in architecture, and she wanted us to introduce this project. We printed these two panels. These are the separate systems that are part of this project, as some of the things that I was telling before, like this, the concentricity of the steps, the tables and their different modulation, the chairs as a pattern overlap with this concavity in this kind of cave, and so on and so forth, going up to the most technical apparatus that is embedded in the project. But as you can see, that it is designed like the air conditioning or the fire systems or the lighting system is designed as part of this kind of same organization, same production. And we produce this drawing, and the other outcome, and this is the final thing I want to show, it's this text that I produced for this magazine. This is a magazine for that is promoted by the College of Architects in Buenos Aires. Ciro Nagle, with the person I'm working with, edited this number, and he proposed the topic of superdigitalism and how to. He invited a number of people, among which this is what I'm going to show you. This is my text, but people that for me are like the people I like to have dialogues with and I highly respect, like Luis Ortega or Marcelo Espina and Georgina Hulrich, or I don't know, Pablo Iroa, Hernán Díaz Alonso, people like maybe some of them you've crossed paths with, and this kind of pool of thoughts of how do we speak about the digital now, no? After, let's say, the first condition of the digital has happened, after, let's say, 20 years of the digital revolution, how do we rethink the problem of the digital? And then I wrote this piece that proposes, let's say, a way to not fall in between this kind of very positivistic or purely instrumental understanding of the ways we look at organization. As you've seen, everything that I've showed you has embedded algorithms and embedded scripts to be produced, but that's not what I'm showing. I'm kind of showing more like what we want to achieve and how do we want to dialogue culturally within the discipline with that. So that would be one of the positions, to kind of embed it so deep that is obviously the inherent part of it. But then also it synthesizes and embeds, and it allows you to kind of contain manifolds of forms without falling into sort of ideological or aesthetic biases. So that would be another one of the points that I feel like I would like to pursue. And at the methodological level, it also proposes internal consistency and the idea of accumulation of critical mass as a process for design. And the objective would be to kind of be able to generate projects that are conscious of the meaning that they have regarding the predecessors that they kind of build for themselves, without that meaning that you linearly decline from your precedents, but quite the opposite, that the project is neither a merely open-ended process, but it's not either a typologically closed object. So sitting in between these two conditions would be, I think it's a challenge. It's not easy to work within this kind of uncomfortable terrain, but that would be somehow the underlying proposal and maybe provocation. And you can see more in ISU. And yeah, this is what I prepared for you today. Just kind of a sneak peek there, and I hope it came through well. And thank you for listening.
Thank you, Anna. Can you hear us?
Yeah, yes.
Good. Yeah.
Thanks.
If there is any sort of direct question, maybe people can leave the message on the chat room, because we've got another lecture by Jaehun and Charlotte. So maybe we can have a discussion all together after that.
Yeah,
Is that
actually,
okay?
Mathilde is going to present, and now.
Oh, sorry.
Okay.
Yeah.
Yeah, sorry. Yeah, and then we can. Yeah, but definitely, I think that would be great. Like people can write in the chat, and then we do a shared.
Sure. Yeah. Okay. Matilda, maybe you can just start straight away then. Yeah.
Okay. Can you see my screen now?
Yes, but you have all the panel
It's not the
basically.
full. Yeah.
But then I can try with it, but I'm not sure it's going to work with the video. So my name is Mathilde Redoute. I met Anna because I'm also a PhD candidate at the Architectural Association. I did my study in France, Paris, and I went to work for Ishigami. So this is also how I met Ko and Hijun. And in the same time, I was doing my master in Paris. I was going back and forth. And I also co-founded a collective of architects called S'il te plaît, with 9 other architects from different countries, and we all work together depending on our interests. So this is the work it's a melting pot of work I had the luck to work on or still working on, depends of which one it is. And today I want to introduce you to 2 of my research, and then very shortly to 3 projects. I have a video and I hope it's gonna work. So this is the next slide. Okay, let me know if you hear the sound.
From Paris to Alt. Alt is known for being the beginning of the cliffs in the Bacardi's littoral that are eroding. What is erosion exactly? It is caused 80% by the rain and 20% by the ocean's waves, transforming the cliff into little rocks, famous in Asia for its aphrodisiac power. So if we consider Alt as a big amount of pebbles, we could just sell the village to China. But hey, wait, there is something on top of the cliff. Inhabitants keep building houses on the beach until the village at the top of the cliff started to get developed through houses in the end of the 19th century. After World War II, Alt became one of the most famous seaside resorts, attracting lots of tourists that came to enjoy the beach. Need to protect the village so Atlas could help support Alt. But this territory is also famous for its atmosphere. From Victor Hugo in 1837, through paintings from Firmin Gérard in 1870, or Saint-Riquet-Cognier in 1874, movies from Agnès Merlet, Les Filles du Requin in 1994, or Guillaume Braque on Mode Sans Femme in 2012, or Michael Kenner in 2009, until Lindbergh captured the Daft Punk in 2013. Alt fascinates. We could call Gary to build a cultural museum. It would enhance the artistic atmosphere, but wouldn't solve the erosion issue. The village would just keep eroding and eroding. As people have lost their territory, we could give it back to them by occupying this place. but alt is a matter of time and space. After studying the erosion, scientists have come to the conclusion that the land is eroding approximately 50 meters per century, 5 meters per decade, 50 centimeters a year, or 1.36 millimeters a day. According to that statement, the government has established a risk prevention plan, creating the danger zone. Let me explain with an example. This is Marguerite and her family. She wanted to buy a place close to the sea. So she chose the city of Alt and found the perfect plot by the coastline, where she built a house. And did you know that when you buy a plot, you own the whole portion of land from the Earth's ratio centre up until the sky? And everything that falls on your property without any human intervention will become yours. But one day, the cliff fell with their home down on the beach. They got a refund for their lost house, but not for the land, especially because their plot still exists on the French Castade. So they continue paying taxes for the plot, even though part of it is now on the beach. How many plots are concerned? On the low tide, there are 36 plots on the beach, equivalent to 2,000 square meters. While on the high tide, there is no surface anymore because the sea is covering the land. In this territory, there are 4 laws applied, and it's hard to know which of them to obey. The local plan for urbanism, covered by the Risk Prevention Plan, overlapped by the Coastline Act and the Maritime Law. According to the law, the beach terrain is unbuildable. What can Marguerite do with this territory? She has 7 possibilities. Build a 5 square meter floor on footprint and make it up to 12 meters high. Build a pool inferior or equal to 10 square meters. Create a greenhouse up to 1.8 meters high. A wall up to 2 meters high. Or protect your property with a fence. Or a wind turbine up to 12 meters high. Build a terrace up to 20 square meters and 0.6 meters high. How to use this law. This is Marguerite's plot. She can either create something on her own plot, or she can join 1, 2, or 3 neighbours to extend her rights. Other owners can have their possibilities as well. From the 36 single plots, we can assemble 18 biplots, 5 triplots, and 2 quadruplots to occupy the beach.
This little movie was made in Alt next to Etretat, and it was commissioned by actually the City Council of Alt at that time. It is realized with diverse architects, and it was an idea to look at the legislation and the erosion issue. So first we map the whole coast, and after looking at it in an official map and cadastre, we found that there's a slight difference. So people are still paying taxes on it. And basically we wanted to give back the territory to the people who lost it, but the territory is already on the beach. So we designed all these artifacts. So for us, all the elements you could see, like the wall, the fences, everything would be kind of a materiality that can be aggregated together to create a new kind of figure. So you can see all the figures here. And the question of legislation inside it is actually something that is very important to me. So I'm going to go back to the next one, if I can. Okay, it's something that really interests me into my work, and it's something I'm working on the Paris local, actually, urban legislation map that is being renewed, and through the idea of the archipelago within the city. And looking at this idea of city within the city, we find that the parking plots in the street of Paris, not the building, are maybe what I can say the last hope to transform the city of Paris, which is under already a lot of historic supervision. So looking at all the plots together, it turns out that all of them measure 133 hectares, which is actually the third smallest district of Paris. So it is a huge archipelago of city within a city. We study it like a normal architect would do. So basically we try to draw plans and understand how it was working, kind of a language that we had to understand. But we couldn't understand exactly what to do with it because it's very small, it's 9 square meters. But luckily for us in France, it's also the minimum size requirement to rent domestic artifacts. So looking at it, we find out that according to the legislation, there's 4 actions that are possible: park a vehicle, perform constructions, and put an object on it. So the question we ask ourselves is, what is actually a vehicle? And hopefully the law doesn't actually give a clear definition. So we had to look at dictionary, and it is considered as a vehicle any machine likely to move by its own devices. So taking this definition of what is a vehicle and putting it in the domestic, let's say, machine, we design it a lot of artifacts that could be placed on the parking lot, but could also be used to actually live. So here, for example, you have the house wheel that is turning depending on the object of and the way you are actually using it on the people. So the second question is, what is a construction site? And it is considered a construction site each ephemeral structure, like for example, scaffolding, that are attached to a site during a renovation. So basically, you just have to ask permits that are given to you very easily in France, and then you can build this kind of ephemeral balcony that can last up to 6 months, and put that just in front of your building to extend your building. And lastly, the question is, what is an object? And how I showed in the previous video, it is considered as an object, a device that doesn't actually need a building permit. So we also imagine a different type of artifact that can be placed around the city by the inhabitants to help them actually move around. And the end of this work was the production of this booklet, which is the cataloger of all the parking places in Paris. And through it, you have all the definition and all the artifacts with the very specific legislation to take back this territory that is the parking plot of Paris, and that won't be used anymore according to the city mayor, because the car should disappear. But giving back this project to the people, we find out that people actually create different kind of structure everywhere, and it will soon become a mess. So we try to actually design a legislative genetic of the parking space of Paris that we gave to the people, and we after asked them to hack our own legislation and to hack our own terms, like we did with the French legislation first. So we try to see what is actually a parking plot. Is it continued, or is it an island? Is it attached to a building or not? Is it attached to, like, which kind of building? Is it a public, a private one, a park, like all these kind of views that are very different. And at the end, it turned out that there are only 32 situations in Paris. And then we try to create the legislation for each situation in Paris, according to the light, according to the shape, according to the use of each. When we did this study, it was 3 years ago, and at that point, it looks completely absurd when we presented it. We sent it to the city mayor of Paris, and they never replied at first, which, I mean, we were expecting something like that for sure. But then the COVID happened, and they turned all the parking lots in Paris as a terrace and has an artifact. that can be extended from the cafe and from the terrace because of the distance. So suddenly our whole study took another interest for them. And basically now we're working with them to develop the local urbanism plan of Paris and to actually put back this artifact, but in a sense that could be shared and in a more common and safe way. So to give back the freedom to the inhabitants of each district, but with their consent and with an agreement of both. That is something I call the common, and is something I'm looking at in my PhD right now. But also I have to say that these two studies about legislation and legality led me to design three pavilion or project that I'm going to show you now. The first one is called the Wheel of Green Pavilion. So it is a pavilion that was designed on the parking space outside the park for a huge festival in Paris. I designed it also with the engineer Jun Sato. So basically, we take the scaffolding issue and we take the object kind of legislative gap or loophole to design this object and to put it at the entrance of the festival. So it would take a kind of the shape of a template or something you can see from very far away, and that can also help the people to get some shadow during the very hot weather, because of course this festival takes place during summer. Here you have some details about the construction that is very easy to assemble and of course disassemble. And it is also very slight structure, so it doesn't go into the ground or it's integrated into the ground. And that was the whole balance we were looking for. And secondly, with the city of Paris, we're also designing new furniture. So basically they launched a competition to design new type of furniture, and it was a completely open competition. And we proposed to implement an object that is actually made for the bees, because bees are now completely destroyed by all the toxic products in the countryside of France, in all the countryside of France. So basically, apparently, to save the bees, we have to bring back the bees to the big cities. And we propose to implement all these kind of little, what we call ruches in France, everywhere in the city. And so we find that after looking at, after mixing the parking plots area map and all the legislation according to bees, because they are insects, basically they need 500 meters to move around, they need to be close to a green space. I mean, there's a lot, of course, of needed to ensure a safe way of implementing bees back to the city. But luckily, we found out that we can place 1,350 bees everywhere in Paris. And this is a project that is still going on with the city of Paris, as you can imagine. It is quite a difficult one because it's kind of a wild insect, but it's something that is still going on after the first study that I show you. And lastly, I'm also working on more domestic scale project. And this is one that I designed for an exhibition with MBL, Yudo, and Suteki. And basically the whole idea was to look at houses that was already existent and add a new use to it. And it turned out we couldn't really design something new according to the legislation. But if we try to look at the materiality not as a wall, but has a transparent material that can take another shape and move, so like a fabric, then we can find a loophole in the legislation to actually implement a new spaces on the second building that can take the shape of a cabinet that we can see here. So at first, the ground floor was like cabinet of architects, and after it was a little house. And we could actually design this project because we were playing also with the term of the legislation. So basically during the whole study I'm looking at, I'm always looking back and forth between what is legal and what is in the legislation, and trying for both of them, using it as a tool and trying to both of them to work together to give back territories to people, to give back freedom to people, but also to create a city and an environment actually that can be used by everybody in a more common senses, and this is what my thesis is about, what is exactly common and how we can work within this private and this public sphere. So this is, yeah, all for today. Thank you so much for listening.
Thank you, Mathilde. Let's just move on to the next lecture, and then we can probably hold on any questions or comments that you might have after this lecture. Jaehun and Clarence, Charlotte, sorry. Are you there?
Yes, we are all here.
We're here.
Okay.
Let me share my screen.
Yeah. Maybe before you start your lecture, if you can introduce yourselves, that would be great.
Yep, sure. Yes.
Thank you.
Oh, sorry. Can you give me like 10 seconds? I'm so sorry.
I can start with a quick introduction of us. So I'm Charlotte. These are my teammates, Jaehun and Clarence. We're a team of designers and researchers, and we first met at MIT a few years ago while we were studying for our Master's of Architecture. Our last semester was the start of the COVID-19 pandemic, and that's when we collaborated on our entirely online MRD thesis, which is a project that inspired a reciprocal research design methodology, and that's what we'll be talking about today.
Thank you, Charlotte. Oh, sorry. Today, instead of a traditional lecture, we're going to tell you a story of a single steel beam, one that takes place 50 years in the future, based on our research in the present. We'll combine methods from scientific research and scenario planning to push beyond the boundaries of traditional architectural practice to face the unpredictability of the future, not with prediction nor with certainties, but with possibilities. While the story we will present today questions the pervasiveness of steel in the built environment, it is our hope that this reciprocal research design methodology could be expanded or applied to other issues of global complexity. Scenario planning provides a means for us to build not only resilience, but also a commonality through which we see the future, a design unity which can help build consensus in an increasingly fractured world. This methodology allows us to prepare for the future by providing a context for speaking about the unspeakable. We'll also present through a video, but we'll narrate through our own voice. You can also watch the video in the QR code. We'll share it later.
A992 was a custom steel H-beam in New York City's Folk Art Museum. It supported the second floor landing, providing visitors with a stable platform to view the museum's iconic bronze facade. The high-strength low-alloy Colombian vanadium structural steel member was produced out of 3 flat-rolled sheets welded together at ArcelorMittal's Coatesville, Pennsylvania factory. The United States produces 3.5 million tons of structural steel annually, nearly 1.1 kilograms per person, in 12 structural steel mills across America's Rust Belt. 37% of all this structural steel ends up in non-residential construction like the Folk Art Museum. On average, 69%, or 61 million tons of US steel is produced from ferrous scrap, Recycled content for structural steel is even higher at 89%. But there are still carbon costs to low carbon methods of production. A992 had lived many lives before it was a beam. 80% of its composition came from ferrous scrap. The remaining 20% of its composition came from prime steel shavings brushed off of factory floors. All these fragments were fused together in the electric arc furnace in Coatesville, Pennsylvania, which processes 900,000 tons of steel a year. Once A992 was fabricated, it was trucked to the Eastern Steel Corporation in Brooklyn, one of 35 steel service centers in the New York area. Over 70% of all structural steel used in construction projects in the United States flows through some 1,120 service centers, which act as large warehouses. After only a few weeks in the service center stockroom, A992 was cut to length and trucked to 45th West 53rd Street, Midtown Manhattan, where engineers estimated it was supposed to stay as long as half a century. But in 2014, A992 was moved yet again. New beams arrived to support scaffolding for workers to painstakingly dismantle the bronze facade panels. Oxyacetylene torches and reciprocating saws descended on the skeleton of the museum, severing A992 from its cross-bracing members. The remnants of the museum were loaded onto a flatbed truck and delivered to metal scrap processor in Jersey City. A992 had become one of the 2.4 million tons of steel waste that New York City generates every year. Of the 100 tallest internationally demolished skyscrapers in history, 23 are in New York. 60 of them were steel structures. They lived for only 41 years, while the average lifespan of structural steel is 52 years. A992 lived to be just 13. Even after just 13 years, the alloys that constituted the complex specifications of A992 were lost. The beam was simply dragged into a scrapyard where it was stripped of its cultural and technical identity. A992 would live again, but only after the wholesale destruction of its inherent self. Even in its diminished form, A992 remained a commodity. Due to rising demand in emerging countries, its masses found it more economical to ship the piles of scrap far away. A992 was ultimately trucked to the port of New York and New Jersey. From Newark, it was shipped 5,000 miles to Turkey's port of Mersin, where it was forced to change its name to HS720, ferrous waste and scrap. The 3.3-ton beam was just a fraction of the 3.8 billion tons of steel scrap the US ships to Turkey each year, over 30% of US scrap. HS720 was melted down in an electric arc furnace owned by the Habas Group, one of the largest steel scrap producers in Turkey. The alloying atoms that had imbued A992 with its strength were now considered toxins, too volatile to be recycled. It is unknown what happened to the rare minerals that were liquefied in the furnace. But the raw iron was extracted and turned into rebar, Turkey's most manufactured steel product. (27.5% of Turkish steel is exported as rebar. In 2014, 27.8% of this rebar was shipped regionally to the United Arab Emirates and to Egypt, but 20% returned to the United States. When A992 finally reached the end of its life, it was embedded in concrete. Pneumatic hammers broke up massive slabs of the rubble, recovering 68% of steel. But the remaining 32% was either destroyed in the demolition process or simply abandoned because it was deemed too costly to retrieve. A992, once a high-strength steel alloy, had been reduced to irrecoverable construction debris. A992 was reincarnated many times, sometimes before the end of its designated lifespan. It likely traced and retraced its steps many more times beyond what is outlined here. A992 weighed only 3.3 tons, a fraction of the 87.9 million tons of steel that the US was producing per year. Steel was lauded as being 100% recyclable, but moving even in this comparatively small mass accrued a heavy carbon cost across the many thousands of miles it traveled in its life. By 2020, half of all waste generated in New York annually, roughly 6 million tons, was construction and demolition debris. In order to be recycled, steel was shipped to scrap processors and transfer stations, where they lay in wait for the highest bidder. Like A992, many pieces of structural steel traveled the globe to find a new home, a new economy willing to mass produce large amounts of low quality steel. In the continuous reforging that followed, they were doomed to lose the precious alloys for which so many landscapes had been mutilated. In order to build upon the city's 2020 goal to eliminate landfill waste within the next 30 years, the New York City Council enacted a radical piece of legislation. Bill S9502 banned the export of waste beyond borough boundaries to take effect by January 2040. Manhattan, which generated astronomically more waste than it received, was disproportionately affected.
By 2070, Manhattan had become the new epicenter of urban recycling. At 0100 hours, a shadow passes over Bryant Park. An exoskeleton winds its way up the W.R. Grace building. Manhattan's latest rezoning has spelled certain doom for the iconic structure at 1146 Ave, which will be the 27th mid-century building to be demolished in the last 3 months. In the early hours of the morning, robotic claws rip the building limb from limb. Curved and straight steel beams land on the back of a waste hauler, operated by one of the city's 250 public waste contractors. On this crisp March morning, over 1,200 haulers are roaming Manhattan's even-numbered avenues, blanketing the peninsula in a barcode of alternating pedestrian and supply thoroughfares. As the hauler continues up 6th Ave, beam C17 jostles against an old Bertoia chair. After 40 minutes, the beam has reached the midpoint of the 47th Street Canal, one of 6 water wasteways that cut 10-meter horizontal bands across Manhattan. Canal 47 begins at what was once the headquarters of the former United Nations, now the site of Amazon's 4th New York office. The waterway continues west through Hell's Kitchen, a 3,700-meter-long connective sinew between residential and corporate neighborhoods. During the day, the area is a hub of pedestrian activity. Noise floats down from the roof terraces that form the extension of the High Line. But it is past the 10 p.m. curfew. The 602 digital turnstiles will not scan pedestrian access codes until the sun rises. At 0200, the hauler docks silently at one of the 8 garage ports on the south side of the canal. Under the terrace and under cover of darkness, 28 tons of waste from the Grace building are sorted by material. 16% of the waste is structural steel, to be classified as either reuse or recycle, and then loaded onto a color-coded barge that will travel west towards the Hudson River, the southern artery of the wetwork. The 100-foot barge is just one of dozens, a parade of segmented bodies dotting the green water of the canal. At 0400, a crane lifts the 2020 Toyota Camry 200 feet in the air. It was among the last private vehicles to exist within the city. The car is loaded onto the vessel, now a self-sustaining sorting facility that processes 28,000 tons of waste every day. Industrial jaws tear doors from chassis, limbs from body, continuously deconstructing the object as it travels 16 stories down the gravity-fed honeycomb. With surgical precision, robotic arms sift through the pieces of flesh, sorting them according to size and material. In the steel section of this forensics lab, a small piece of the Camry shell is extracted and inserted into the Tesla mass spectrometer, where it is analyzed for its molecular composition. 6 centiseconds later, more claws grab the shell and divert it to one of the 452 conveyor belts radiating from the lab. The shell lands atop the frame of a forgotten treadmill and a 4.8-ton beam C17. While distinct in form, these 3 artifacts are nearly identical in chemical composition. C17 then passes over the 30 active tracks at Hudson Yards to arrive at the electric arc furnace. Once nothing more than a parking lot, the 2.2-acre site has been transformed into a structural inferno. Today, along with 120,000 tons of steel, the beam will be reborn again and again as the city relentlessly melts and remolds its steel. 0700. A container vessel docks inside a warehouse at Pier 53, one of 4 500 square foot holding pens for fresh steel. The steel is sorted according to composition and form and stored in this climate-controlled facility alongside overflow art storage for the former Whitney Museum, which was acquired by MoMA in 2047. An automated system continuously evaluates the accessioning and deaccessioning of steel. A new H-beam is rejoined by a forebearer, one that was allowed to bypass the furnace. Only a slight color difference indicates their distinct paths. This morning, 8,293 beams stare out at the river at a grid of vortex turbines that populate the Hudson, energy slaves to the 400 kilowatt hour per ton furnace. The beams are protected from the corrosive salt air by the warehouse's synthetic skin, stretching over a screen made from 12,000 recycled steel rods. Soon, the steel will be called upon, dragged back into the water to serve the counterclockwise cycle of unbuilding and rebuilding in this mega metropolis. By 0900, a steel barge passes under the bridge at 61st Street. The bridge is a twin of that at Canal 47, Manhattan's answer to repairing its 100-year-old infrastructure. Each bridge is part of a recognizable set, with bespoke connections to the existing buildings that support it. Simultaneously unique and generic, these replicable structures will save the city nearly $50 billion over the course of the next century. Technically, these net zero processes are considered green, and in 2080, the peninsula is designated the first ever LEED Palladium city. In 2020, the story of a single steel member is told over the course of a decade. By 2070, the reincarnation of a single steel member has been compressed into a single day. Manhattan is now the epicenter of an epidemic of melting and remolding steel.
The scenario that we just presented provides a plausible future that operates within the confines of the current capitalist system. It highlights the absurdity of our current practice without becoming absurdly unrelatable. The goal of the scenario design is not to predict the future, but to put into perspective the consequences of our current practice. While acknowledging that we as designers operate within a larger geopolitical context, in designing futures, we actually reveal and question the assumptions and perceptions that shape our current design practice. Thank you.
Thank you very much for your wonderful presentation. Right, from the audience or from those who's joining us by Zoom, yeah, if you have any questions, can you just raise your hand, please? So let's use the time. Come on.
No.
We had a very sort of a in a way different presentations today. Yeah, was someone try to say something? I just missed. No? Questions or comments? The students? They are very quiet today. I don't know what happened. It wasn't like this, yeah. Is it because we're all very tired after tough working over the days? Oh.
Thank you all for your presentations. I have a question for Anna's project. In the first 3 projects especially, I noticed that there's like you're usually using one material, and it seems to me there's an idea about how it's constructed. For example, you mentioned the weavers, and also like you have this template of A3 pages, and then in one of your projects, you talked about how the students laminated the plywood. So I'm just curious if who constructs the structure is a part of your thinking, and whether you think it changes the outcome.
Right, thank you. Yeah, thank you for that question. I think it does change. In the first project, actually, it was part of the museum's brief. It was about energy. It was called energy excesses. So it was looking into how we manufacture, and we chose to work with these people that were. It was not a robot. It was not a professional of something. Like it was not an architect trying to do something, but just like to the root of the knowledge. In this case, of crochet. In that case, it was very much a decision. It was also a reivindication, because these women that did that work on very low wages. So I didn't go into all that today, because I was making kind of a point of the kind of the general for projects, but I think there was a discourse there as well of how we would claim that space of work for them in the city. And they work in a particular neighborhood. There is a story behind it. And we were interested in that. So that was definitely, and also the clash between our way of thinking and the way of building it. Then we transported everything. It was a huge problem to transport it to the US, because if you take textile into the US, it can contain like organic things. So it was a mess. But I think yes. And then the other 2 projects, because we work with students and we work with our hands, and again, we didn't have the resources in terms of fabrication, but we thought, we didn't need the kind of actual super sophisticated thing. We needed the thinking. So I think the lamination of the chair, if done perfectly and smoothly, maybe it produces a less interesting project. I think because it kind of fits into the categories of representation. And I think there's something about representation in everything, which is we don't produce models to represent what we get. We produce models of control. And then what we get is slightly different. And the idea of emergence there, the emergence of intelligence, is in the process of the making. So that it's definitely cut out if you kind of process it in kind of technologically refined kind of mediums. So yeah, you're making me think also. I think it could be like the whole lecture could be kind of approached in that direction. It is a really nice question. Yeah.
Thank you.
Thank you for the question, Catherine. Today, actually, we were expecting kind of to have some sort of a comparison or discussion between the two presentations, but I found it quite in a way different. And so I just to buy some time for for students, if I can ask Jaehun about the second presentation. I might have missed the first part, but was this your thesis project by three of you?
Yes, it was joint thesis, all three of us. So we started our thesis during the pandemic, so we had to go through this digital collaboration. And yeah.
This
Okay,
was
good.
just a part of the thesis.
Okay. No, because it feels like it was very well packaged and well presented in a way, like perfectly presented today. So maybe the students probably found it difficult to find a question or something like that. So I just want to ask after you three of you sort of completed this thesis, and then has this thesis left any sort of further investigation or homework for you guys to continue, or how, like after you graduate, and some of you have started working in a slightly different, I don't know, like in the field of architecture. And then I just want to ask you about your sort of attitude and how you want to either continue, or what left you, what has this thesis left you, sort of what kind of feeling?
So like I just said, this was only a part of the thesis. So we showed one story today for our thesis. We had 3 stories, and the understanding when we went into the project was that this was a huge tangled question and issue of global complexity. And so the ideas were that it could be an ongoing project. So it wasn't like the 3 stories were a beginning, a middle, and end. They're just each different snippets in the life of the global steel supply chain. So we've been slowly adding to it. Like Jay said, we were in the pandemic when we started, so we're certainly used to collaborating digitally. We have all transitioned into more professional architecture roles, but we work at firms that are largely supportive of more of the research side of things that we're all also interested in. I don't know if anyone else wants to speak to that.
Maybe for me and Clarence, we are working at a facade consulting company. So we basically help other architects design complex envelopes or facades. And Clarence, we haven't took any, I guess, we had conversation about taking this research into further investigation. But we had some like small talks about how we can expand the area of the materials that we can explore. So we start with the steel. Now we're working at facade systems where you have where you see a lot of aluminums, glass. So maybe we could, the idea could be extended to some sort of silica materials for making glasses. So sand could be the base of the next investigation. And we're still looking for like other opportunities where we could tackle like one specific material to kind of see the entangled network.
Yeah, and I think part of the reason we chose the entangled network, just from a student's perspective, is that we were sort of we wanted to push beyond the traditional studio research setup where you maybe do 1 to 2 weeks of intense research before embarking on a studio project. We really wanted to spend an entire semester integrating research and design and iterating and oscillating back and forth between those two.
Yeah, I think for us, I mean, what we took out of this was trying to focus on something extremely granular and use that to produce a side of speculation in the future, with that side of speculation generating, productive discussions. for us, for the story you just told, like everything from that, stemmed from simple research into just looking at a steel beam in America in Manhattan and saying, okay, where did this come from? Right? Like, okay, it was produced in a factory here and probably in Pennsylvania based on, logistics, this factory, where does it get its steel from? Okay, it's on electric arc furnace, which means it's probably recycled, which means it's getting steel from itself somewhere else. And I think just based on sort of continuing to, build upon sort of the layers of research, that sort of generated the whole scenario. And so the scenarios aren't meant to be sort of predictive of the future in a way. We know that what we presented was sort of a very radical, presentation of New York in the future, right? That was sort of the extreme. Well, what if we went all the way? But, in a way, it was sort of says, okay, like if this is an extreme, like what can we achieve? Like what is on the spectrum, what's achievable for us? So for us, it was always mainly about being able to look at something, identify the networks around it, and then project that into the future and how it will affect sort of a larger landscape. And then from that landscape, look at it, question it, and start to talk about, okay, what looks weird to us? Why does it look weird? What looks correct to us? Why does it look correct? And so on.
Good, thank you. No, I think the students today might have been inspired by 3 very different projects by Anna, Mathilde, and 3 of you, Jaehun, Charlotte, and Clarence, right? Yeah. But also the reason why I asked this kind of question was that I found it very, I found a great potential to work with all of you in the future, so that you can kind of continue this investigation with this kind of experimental workshops. So that's why we wanted to sort of open up this discussion. Do we have any other questions? Oh, yes.
Actually, I have one question for the first lecture. And I remember it was like 3rd or 4th project. I guess it was the auditorium project. And on that project, you used the phrase like building in the building. And I want to hear one more time, like so what is the difference from like the previous auditorium and the auditorium that you built, because you used the phrase like building in the building. So I want to hear more about the phrase. So explanations.
Right. Okay. Yeah. No, I said that because actually the building had an extension of 1 more floor, and that is where our project laid. So the place where the project is located was the previous terrace, so there was nothing there. And then it grew one floor, and they built like this kind of green terrace. And actually, what we found, and that's why somehow, I mean, I think there are at least 2 reasons why I'm saying a building in a building. One is because we found that we had a space that had a certain kind of restrictions of height, but they were enough to kind of do the concavity problem, right? So we found that because it was a terrace, we had a distance from the slab, the underneath slab, and the new slab that allowed us to do the concavity, even though it's very light, as you could see, and the same with the top. So that is the first, because it is an addition. So in a way, it doesn't have an existing structure, and we could kind of blow up the space within these restrictions. That's the first kind of more practical reason. And the second reason is kind of conceptual, which is the fact that we decided to build a facade around it. Like all these, the profiles, the aluminum and modulated profiles and the way they reach the corner, that was very difficult to convince the client. In that case is the university, because of course they would have put only like this kind of a wall that's like opaque wall, like the cheapest that you could achieve, that with acoustic filling or whatever, but they wanted a box, right? And we said, no, we're going to build a facade inside of the building. And I think that is what makes it a building within a building. The fact that it has its own facade that you can see outside of that space into an interior. You see the people passing by, you see that circulation. And that is a conceptual thing, which is it's like a pavilion inside a building, sorry, because it has its own facade. That would be the double reasoning. One is more practical, the other is more like of the decision of the perimeter as such. Does it respond?
Yeah. And I have one more question again about that project. So in that project, it seems like there are like differences in the level, the height of the floor, and I can't understand why you have such the level different, because the tables have like different levels, so students can gather like 2 or 3 or 1. But I want to know the reason why the ceilings also have the level difference, like the bottom, like the floor.
Yeah, the differences are 13 centimeter differences. So it's like, and it produces that, like in the case of the, I mean, I understand that you're saying, okay, I buy the kind of table part, no? But in the roof, it's mainly acoustics. It is an acoustic reason. The pattern that it follows, it's more flattened. So it's more about sound. While in the bottom, it has this kind of escalating, no? Like you have the floor with this 13 centimeter thing, then you have the tables with this kind of 70 centimeter. So it kind of explodes the steepness, and it makes it apparent, like the tables make it apparent, while on the top it keeps more flattened. And I think well, I mean, definitely we tested acoustically, we simulated the sound, but also the question of the integration of systems, air conditioning, lighting, the distances to the tables are different. So we concentrated more systems in one side than others. So we like the idea of customizing a little bit the different areas in the relationship with the heights. So we found that made the project more multiple, like this idea of manifold conditions within something that is a unique space. Like it's only one space, but all of a sudden it has different conditions. And that's why also we kept it, because we could have made it work acoustically with less difference. But that kind of grew on us, let's say. Yeah.
Thank you for your reply. And for the last, I have one question for the last lecture. And because like we were discussing about the modeling images that you showed us when you showed about the images of US, and we were talking about what kind of software they use to design such a modeling file. So could you tell us which software you use to design those mass models of the buildings? Yeah, I know it can be a silly question, but you are so curious.
Oh, it's really simple. It's just Rhino and V-Ray.
Thank you for the reply.
Right. Well, when some other students can wrap up the recap the lecture, maybe there might be some questions, but then we can probably email, to you all over there. And shall we wrap up then? Yeah. Thank you very much for joining us, all of you. And thank you again for taking your time for the students. Yeah. Let's just call it a day then. Yeah. Thank you. Yeah.
Thank you so much.
Thank you,
Thank you, everyone.
Bye.
Bye.